Hey guys, the title of this video is Solving Absolute Value Equations Part 2. So you got the first part of the lesson in class, and this is the second part where we're going to look at a little bit trickier absolute value equations. So our learning target is still the same as in the first video. I can solve an absolute value equation. So we want to try to remember the steps that I gave you from the first lesson. So if you want to get those notes out so you can refer to those steps, that would be a good thing. If you're going to do that, go ahead and pause the video now to get those notes out. And our first step is to isolate the absolute value on one side of the equation. Well, you should notice now that the 3x plus 2 is what's in the absolute value bars. And that is already isolated. So step 1 is taken care of already. Step 2 is to create two problems. So I'm going to go ahead and write my two problems now. So I've written my first problem, 3x plus 2 equals 4x plus 5. I just completely dropped the absolute value bars for the first question. And for the second equation, I'm going to put 3x plus 2, and I'm going to change all of the signs that come after the equal sign. So that's going to equal negative 4x minus 5. Okay, and step 3 tells us to go ahead and solve the two equations. So let's look at the first one. We've got 4x and 3x. I really don't want to have both, so I'm going to choose to eliminate 3x by subtraction. And what I do on one side, I'll do on the other. So bringing down the 2 and the equal sign, 4 minus 3 gives me 1x plus 5. And then continue solving by eliminating that 5. And we get that x is equal to negative 3. Let's do the same thing to solve on the other side. This time I want to get rid of the negative 4x, so I'm going to add 4x to both sides. And that's going to be 7x plus 2 equal to negative 5. Subtracting a 2 on each side. So that gives me negative 7. And then divide by 7. I get negative 1. So I've got two possible solutions here, but I don't know for sure if they are until I go through step 4. Step 4 says to check the two solutions. So to check these, I'm going to actually substitute them into the original equation here and see if they make this equation a true statement. So if I were to replace this x here with the number negative 3 and this x with also the number negative 3, would that make that equation true? So let me just write that out here. So now we just use the order of operations to evaluate each side and see if the two sides are true, or see if the two sides are equal. So using the order of operations, on the left hand side I got the absolute value of negative 7, and on the right hand side I got negative 7. But I know that the absolute value of negative 7 is actually 7. So I get 7 equals negative 7. But that's not true. Therefore, we have to reject this negative 3 as a solution. It is not a true solution to this equation. So we're also going to need to check the other solution, the negative 1. So I'm running out of space here, but I've substituting in the negative 1 to the original equation, and now let's use the order of operations to simplify each side. So this one gave me the absolute value of negative 1 is equal to 1, and I know the absolute value of negative 1 is 1, so I end up with 1 equal to 1. That is true, so that means negative 1 is our only solution. I want to introduce another vocabulary word here. It's called extraneous solutions. Extraneous solutions are solutions that we find by going through the steps correctly. However, we have to reject them because they do not work in the original equation when we go to check. So an extraneous solution is this one here, the -3 that we found. We would call that extraneous, whereas -1 was a true solution. So our answer in set builder notation for this, that's our 5th step, would be x such that x is equal to -1. Example 2 already has absolute value isolated. So we're ready to set up 2 problems. Notice that in the first problem, I just dropped the absolute value bars and wrote everything down the same. And in the second problem, I changed the signs of the 2 terms that come after the equal sign. In step 3, we're going to go ahead and solve each equation, and I will do that now. So here is the left equation completely solved. If you need to take a moment to look at that, study it, understand it, then pause the video now. And here is the second equation solved. So now I've got 2 possible solutions. I need to check those 2 solutions in my original equation to see if they really do make an equal statement. So by substituting and simplifying on my left equation, I ended up with the absolute value of -42 equals -42. Well, that is not going to be true because the absolute value of -42 is positive 42. So that one is untrue, which means that this is an extraneous solution, so I'll reject the -8 as a solution possibility. On the other equation, we see that I got absolute value of -7 is equal to 7. Well, that's true. The absolute value of -7 is 7, so that is true. So -1 is, in fact, a true solution. We will also take a look at set builder notation. We could write the answer in this way: x such that x is equal to -1. The next example needs absolute value to be isolated. So we're gonna begin by dividing by the fraction 1/2. And some of you may realize that dividing by 1/2 is the same thing as multiplying by 2, but I'm going to do that step now. So here's the result of dividing by 1/2, and now we're ready to make 2 problems. So my 2 problems, on the left, we are just dropping the bars, okay, and on the right, we keep the 3c plus 5, and we change the signs after the equal sign to -12c minus 8. Next, we'll solve each of these equations. So with this one, I get -3 divided by 9, which doesn't really divide evenly, but I do know that -3/9 reduces to -1/3 because 3 divides into 3 once and 3 divides into 9 3 times. So I have a possible solution of -1/3. And for the second one, we end up with -13 divided by 15, which 13 and 15 don't have a common factor, so this doesn't reduce at all. So we have another possible solution that's a fraction, -13/15. Our 4th step is to check those 2 really nasty fraction answers, and I'm betting that you guys are going to want to do that with a calculator, so I'm going to do a little giveaway on that one. I'll just tell you that the -1/3 is going to work when you check it, and the -13/15 is not going to work. So -13/15 we reject. -1/3 is the only solution. In set builder notation, we could say C such that C is equal to -1/3. There is one more example here on your guided notes. I would like for you to take a try at this. I want you to try working it out. Come to class with 2 problems solved. Check them. See if your answers are correct. And then whenever I check your notes, you'll get points for trying this. And you'll also get to find out at the beginning of class tomorrow if you actually solved it correctly. We'll start class with this problem tomorrow. Good luck, and I'll see you in class.